Hey everyone, let's talk about reasoning agents. Now, we're going to be using the framework Agno, which I highly recommend. It's been my framework of choice for the last little while, but I think this should be broadly applicable to any framework that you might be getting into, because what I've been learning is that these things really, the concepts seem to really carry over from framework to framework. Also, check out the links below so you can join the community, and I also have some special offers for you as well. But let's jump into things. Now, what is a reasoning agent? Like, what does it mean to reason, right? Well, essentially, we want our agents to be able to think for themselves, right? We don't just want them to take into account what we said and then just kind of regurgitate back what they think the right answer is. We want them to kind of take a moment, think through the problem that we're describing to them, and take into account any of the constraints that we've imposed on them, for example, policies or regulations, things like that, and then go and return what they think the answer would be. The first approach that we might go and do are what are called reasoning models. This is probably something that you've heard of before. I think OpenAI has a reasoning model. There's DeepSeek R1, which was a really kind of hit. It kind of took the space, the industry by storm, because I think it was trained more inexpensively than compared to OpenAI, and it was a lot less expensive than OpenAI, and it did a really great job. This is something that really just comes down to the model. And I want to show you guys some examples of what you might kind of use in order to do that, or what you might expect. In this first example that I have here, what we're going to do is, again, we're using the Agno AI Agent framework, and we're going to use from OpenAI Chat their O3 mini model, which is a reasoning model. And we're going to ask it to solve the trolley problem and evaluate multiple ethical frameworks. And then after that, we're going to also ask it to include an ASCII diagram of its solution. Okay, so we've gotten a pretty solid response here. And basically, it's walking us through everything that it's doing. So you can see that we've given it the problem, as we mentioned with our prompt. And I'm not going to go ahead and read all of this, but basically it is breaking down different types of ethical frameworks that it could use in order to think through and come to a solution. And ultimately, it gives us its diagram and then summarizes everything and says, ultimately, the solution you can choose depends on the ethical framework you find most compelling. Sounds pretty reasonable, right? But it did a pretty good job of thinking through everything and determining not necessarily like the end all be all of solutions, but it was able to kind of get itself, through the problem and think through it. Let's take a look at another example here where we also incorporate a tool into the mix. So instead of asking it to give us a kind of understanding and solution to the trolley problem, let's instead ask it to write a report comparing NVIDIA to Tesla. And the tool that we're going to use to do this, or to help it do this, is going to be the Yahoo Finance tools. So let's go ahead and do that, and we'll see where that gets us. So let's go ahead and try that. Something that you might notice here is that this takes a lot longer. Allowing the model to think means that it's going to take more time to go through and solve the actual problem or to give you a response. Not only that will it take more time, but it will also actually use up more tokens. So you're going to end up having to pay more money. The reason is because its thinking is generating tokens, right? It's generating content, which you're ultimately charged for. We can see here that we do get a write-up of both of these companies. I don't know that it's, again, like we're not going to sit here and go and like evaluate the correctness, if you will, of this report. I think that'll be in a different video when we actually do talk about evaluation. However, it did a pretty good job of giving us some kind of a report, but we see that it took 23 seconds, or just over 23 seconds. So it does take some time to do this. Let's take a look at another example where we actually are able to customize the reasoning effort of the model. Now, I'm not sure if this is every single model that's going to allow this as part of its API, because ultimately this is from a different package within the Agno framework. However, this is one option that we do have. So we'll say the reasoning effort is high, and we're going to go ahead and ask it to do the exact same thing again that we just did before. So let's go ahead and do that. I would expect that this is going to take a little bit longer. So I'm going to cut it, and then I'll show you guys how long it actually takes in the end. So remember that the other one was 23.3 seconds. Okay, so it looks like this this report here that we got is quite a bit more lengthy. Not only that, but this took 42.8 seconds, so considerably longer than the other one, which was 23 seconds or so, almost twice as long. And so we can customize the reasoning effort, and that's another thing that's really helpful that we can do, right? Now, something that's really important to understand here is like when the exact thinking happens. So what these models are doing is they're actually trained in such a way using reinforcement learning to think before they actually respond. But that's the key thing there, right? We are thinking before we respond, not as a part of the response process. So we're not able to actually, I don't believe that we can use a tool and then evaluate its result or anything like that, and then determine what to do there. Instead, the model is, or the agent is actually going to have some stream of thought, and then it's going to decide how to proceed. That's really all it can do, right? But let's take a look at something a little bit different in example 4 here. So in this one, and let me clear this down here. In this one, you might look at this and think, well, this isn't any different, but there's one key thing that's different here, and that's this right here. The model is set to Claude. We're going to use Claude's Sonnet 3.7, right? But we're going to actually specify a reasoning model. And we're going to use the O3 Mini that we were using before. Why would we want to do that, though? This is a different technique called reasoning model plus response model. And the general idea is that not all models are created equally, as I'm sure you already know. In fact, some models, while they might be reasoning models, are really good at reasoning, where other models are really good at conversation and responding, right? In the same way, I like to think of it as like different regions of the brain. There's, we know about the hemispheres, right and left brained people are good at better at different things. But then there's also certain regions of the brain that handle, let's say, reading or emotions or complex tasks or impulse control. And it's similar in the world of LLMs. LLMs are each individual LLM is trained for a specific idea, a specific set of tasks or characterization of tasks. And sometimes they might be trained to be able to do a lot of different things, and that would be very helpful. But nevertheless, oftentimes even, they can be trained for specific things. And so as a result of that, what Agno is allowing us to do is specify that we want to use this model for reasoning tasks or for the reasoning portion of the task. And we want to use this model for the actual response. And so let's see how this goes here. So let's run this again, do 4, and let's see what this gives us. Okay, now I want to run it one more time, but without the reasoning model and see what the response to that is. So let's look at the difference here. Number 1, this answer is incorrect. So using the model that is better for responses as our reasoning model actually got the answer incorrect. However, using them both together, the answer is correct and the response is pretty good overall. So what this tells us is that we can use a model that's specifically designed to handle reasoning, like O3 Mini in this case, to do the actual reasoning task, which is great because these types of reasoning models are actually specifically designed. They're very good at simple thing, not simple, but like one shot, like just give me an answer. There's a right answer. Let's think through it kind of a thing versus these models here, which might be better at explaining things or calling tools or things like that. So what we're able to do here is we're able to, one, most importantly, get the right answer using both of these together and get a really solid explanation of that answer in the end. Whereas using just this model here, the Claude model, actually ended up giving us the incorrect answer. Let's say, though, that we don't want to use a reasoning model for whatever reason. Maybe there's a limitation with the framework that we're using, or a limitation with the way in which we're building our agent, or maybe it just costs too much money, or maybe there's a different reason, whatever it is. How can we give the ability to a non-reasoning model to also think through a problem before generating its ultimate and final response? Anthropic actually published this idea here back quite recently, March 20th, 2025. They published, and I'll link this down in the description too, They published this article here from their engineering blog talking about the idea of giving a model a scratch pad, if you will, to kind of think through a problem. We're not going to go through this article here, but I would encourage you to check that out if you're interested. Again, link in the description below. Visually, though, you can think of it as I'm sitting here, and when I have to solve a problem, I might have a piece of paper on the side or a whiteboard perhaps that I can draw stuff up and write stuff down and try and give myself a way to document things and maybe break the problem down and to think through it before ultimately coming up with my final answer. This is kind of normal for us as human beings, and this is the exact idea behind thinking tools, as they're called, for non-reasoning models. So what we might do then is, again, use a non-reasoning model in this example, and we will add thinking tools, which comes from, in this case, Agno Tools Thinking. Right there you can see. So I'm going to just put this away so make it a little bit easier to see. And then we'll go and do our Yahoo Finance tools again. And what we're going to do is say the exact same thing that we said before, close to the same thing we said before, write a report on NVIDIA, only the report, no other text. Let's give this a shot and see what happens. Okay, so we got our response. It took 38.1 seconds to generate. It's pretty solid response. I mean, again, we're not going to go through and evaluate this right now, but we can assume that it's somewhat decent at least, right? And we're also going to scroll up here and we'll be able to see all of the tool calls that were made here. So it did use our thinking tools, tool calls, thinking. So it did do this, right? And ultimately, we were able to use these thinking tools that come from the framework that we're using. Something that I want to call out here is two things. Number one, this is the specific implementation in how it works in Agno. I don't know exactly how it would be in other frameworks because I've not looked into that. However, the framework is abstracting away a lot for us here. We certainly Agno is open source, so we can go and look at the code implementation here on GitHub, and I did do that, and it's very interesting how they did it. But it really handles everything. We just supply it the tool that we want to make available, and it handles everything for us. We don't really have to touch much of anything else. There might be more configuration here that we could add, but it's still handling, pretty much everything here for us. So in this next example, we're going to work with something a little bit different. This is like a V2, if you will, of the thinking of this reasoning stuff, these thinking tools, is basically called reasoning tools, right? This is again from Agno, and you can think of reasoning tools as the ability to think, which is what we just saw in the reasoning tools, plus the ability to analyze. And so now what we're giving our agent the ability to do is to analyze the results of each tool. So not just think about how it should actually handle the problem throughout the process of its execution, but also to analyze the result of each tool and then make adjustments as necessary. So let's go ahead and run this and see what happens. So this took quite a while to run. Let's see here, but it did generate quite a bit, but it took a little over 2 minutes to run. So that was kind of a long time. However, something that I want to note here is that the tool calls are kind of interesting. So one, it did actually have a thinking step. So it took some time and it thought through what was going on. However, after that, it actually also called the other tool, which is in reasoning, which is the analyze tool. So as I was mentioning before, the difference between thinking and reasoning is that thinking is just thinking through the problem and describing it, whatever that may be. And then reasoning is the thinking part plus analyzing it. And in this case, we see that both of these things did happen. It did think through it, and then it also did analyze it. And we end up with a pretty long result here, which, again, we're not going to really get into this, but still a pretty interesting result here that I think is pretty cool. The next evolution, if you will, in the thinking reasoning process is actually adding in like a knowledge base. And so this basically would be adding in a vector database. In this case, we're going to be using LanceDB that basically gives our our agent the ability to store information about whatever it is it's, let's say, a domain expert on, and then it can actually search through that information in order to help it answer a question even better. And so this is how we might do something like that. So again, we're going to import the knowledge tools, and we're also going to import LanceDB. We're going to create our docs here, which we're going to get from, let's see, URL knowledge, specifically from this right here, which is docs.agno.com/llms-full txt. Now, really quick note. If you didn't see my last video, I think it was my last video, go and check it out because it actually covers this concept, which is llms.txt. These files are specifically made so that LLMs or agents can actually use the information on your website in a more efficient way. Similar to how, SEO kind of made it so that search engines could understand our websites better. This is right now a proposal to help agents understand our websites better. So go ahead and check that out. I'm actually building a tool that will help you to do that. And automate that whole process. So more information on that coming soon. But for right now, go and check that video out if you're interested. All right, back to this. So inside of this URL knowledge, we're also going to provide our vector database, which basically, as I said, is going to be LanceDB. We're going to create the URI. So we're going to end up with another temp folder directory in here with LanceDB inside of it. We're going to create a table name called Agno Docs. We're going to give it a search type, and then we're also going to give the embedder that we want. This is going to be an Open AI embedder. Agno has a number of different options for embedders, so you can kind of play around with them and try them and see which ones you'd rather use. But this one I think is pretty good. That's also seems to be a default that they use. All right, now what we're going to do is we are going to create the tools here, and so we're going to basically give it access to everything that it needs. Okay, now let's go and actually create our agent. We're going to use GPT-4o, which I think is the model that ChatGPT uses, if I'm not mistaken. But at any rate, let's go ahead and do that. We're also going to load in our docs here. So now what we can do is we're going to ask it a question. How do I build multi-agent teams in Agno? Let's give that a shot and see what happens. All right, now we're done. Let's take a look at what happened. So number one, the response only took 12 seconds, 12 and a half seconds. However, look up here. It had to go through, that's from the other run. It had to go through all of this stuff, which is basically embedding everything and putting it into our vector database. And we can go here and see inside of temp that we do in fact now have, which I guess we can't open that, but we do now have a vector database here, which is awesome. So that took a while. So it's something to be aware of that, like, that's going to take some time. However, we do now have this, and it did actually give us an answer. Now, whether or not this is as good of an answer as you're going to be able to get from the just actual documentation, I don't really know. However, what you could do now is, in addition to just simply asking things like this, is you can ask for help on things. If you're stuck, maybe, right? Like, you could ask for help with stuff. Same thing goes for anything that you may find. There could be another page online, maybe a PDF document that you want to put into your vector database, and this is going to be able to help you do that. So I think this is really, really helpful. Okay, now I want to talk to you about the last thing here that we have on our list, which is a reasoning agent. This is actually something specific to Agno. It's a concept that they came up with and they've implemented themselves. And the basic idea is if we set reasoning to true, it's actually going to create another agent on the side that basically acts as a reasoning agent to kind of think through everything before ultimately giving all of that to the primary agent to formulate the response. And something to note here is that if we don't, as I've done here, I didn't provide another model here, so I don't have this reasoning agent equals whatever here. So what happens in that case is that it's going to use this GPT-4o as the reasoning agent's model. Now, if we didn't want that, if we wanted to customize it, maybe we want to use a less expensive model to formulate our response, we could do that for sure. And then we could use GPT-4o or something else, whatever, to do the reasoning stuff itself. So what's happening here, and I'll run this and then I'll talk through it while we're doing that. How about that, I think? So let's do Python, reasoning agents, and then this is the basic, whoops, this is the basic example. Let's run this. And while that's, let's walk through this. So like I mentioned, this is spinning up another agent on the side. And in addition to thinking through everything, it's also actually evaluating all of the tool calls and everything and basically coming to conclusions at each step in the process and iterating until the overall final response is generated. And at that time, that is what we're seeing here sent back to us. So again, we've got our response here. We ask it to solve the trolley problem. It goes through, it creates that ASCII diagram for us here. And it kind of gives us a walkthrough of its thought process there. So that is another thing that you can do. Let's take a look at another example, maybe for let's say planning an itinerary here. So let's clear this, and then we will go and basic example. We'll do I think I called it itinerary. Whoops, itinerary example. Let's execute this one here. And so we just wanted to plan an itinerary from, I guess we're taking a trip from LA to Las Vegas here in the United States, and reasoning true. And then the model that we're going to use is 4.0 from a specific date of back sometime in 2024. It looks like August 6th. By the looks of it, this is a very detailed itinerary as well. We've got, although it's only taking us 3 days apparently. And something I do find interesting is that on day one, it gave us exact times. I don't know if that's based on anything like how long it should actually take. I mean, we do have, well, some are 1 hour, some are 2 hours. So that's interesting. But then here it just says morning, lunch, afternoon, evening. So interesting that it didn't give us times on the final 2 days. Let's take a look at our final example here. And then I want to kind of give some notes on reasoning agents that come from Agno. So let's do the creative writing / creative writing. And this is going to basically write a short story about life in 5 million years. Okay, so here is our short story. Again, not going to go and read this all, but you know, it looks like a decent story, right? It gives us some stuff, something to think about, I guess, right? Some things that I want to note here about the reasoning agents. So the models that you choose for these reasoning agents need to support structured output. So for example, we have GPT-4o, which is why we used it here. We have Claude 3.7 or the Gemini models, since they have the ability to do structured output via JSON. So keep that in mind when you're choosing the models that you're using, is that they do have to actually, you can't just use any model that you want for the reasoning agent with Agno. Additionally, let's say that we didn't use this model. Let's say here we used, I think it was it was O3 Mini, I think, just like this. Let's say that we use this. Well, O3 Mini is a reasoning model itself. So what Agno is basically going to do is it's going to operate in that reasoning model plus response model that we saw earlier. So basically it'll have two different agents that get spun up. One is for the reasoning, one is for the actual response. So just kind of a note there in how that kind of works behind the scenes. Thank you so much for watching. Check out the links in the description below. Again, I've got a really great special offer for you guys. You can get $200 in credit with DigitalOcean for hosting. They also have some generative AI stuff that you can take advantage of, so you can try it out for free over at DigitalOcean. And then also join the community as well. And so I have some links and stuff for various ways that you can join the community of AI engineers that I'm trying to create here. And then also go and check out the articles that I mentioned in the video, specifically the one on Anthropic with thinking tools that'll also be linked down below. And if you enjoyed this video, let me know down in the comments, what was your favorite part? What are you confused about? What are you trying to learn next? Maybe I'll make that video or a video on that topic next. And subscribe if you want to see more videos like these. Thanks so much for watching, and I'll see you in the next one. Take care. Bye.